In this activity, we'll be creating a program that utilizes new types. New types allow you to leverage the Rust type system in order to make your code more robust and easier to read. Once you're ready, open up Visual Studio Code and we'll get started. Once Visual Studio Code loads, navigate to your Activities directory. We are on Activity 28, so double-click on A28. Once the activity file loads, review the topic and program requirements. Attempt to implement a solution on your own with the video paused. Once completed, resume the video and I will demonstrate my implementation as well as provide insights to the activity topic. All right, let's get started. As we can see, this topic is on the new type pattern. Our requirements are to display the selected color of shoes, shirt, and pants. And we need to create and display at least one of each type of clothes and color. So we're going to have multiple colors with multiple clothes types. Our notes indicate that we need to create a new type for the colors of the clothes, and each new type should implement a new function. We also need to create a function for each type of clothes that accept a new type color specific to that type of clothing. Here we can see that we have some colors provided to us already, so we don't need to create any colors. We do, however, need to create new types for each color, specifically the clothes colors. So to do that, I'll create a new structure, and new types always need to be structures. So we'll have a structure named shirt color, and that will just have a color enumeration within it. This is a tuple structure, as we can see by the parentheses. So it can be accessed with a .0 when you want to access this inner field. I'm just going to copy and paste this for the other clothes items. Next, we need to implement the new function for each structure. And I'm just going to copy and paste this block for each one, and I'll just change the names. So what I've done here is create new types for the color enumeration. So we have a shirt color type, shoes color, and pants color type. And what this will allow us to do is ensure that when we're calling our functions to display the color, that we specifically provide colors for these specific items. So the function that displays shirt colors will accept a shirt color structure, and that will ensure that we don't give it shoes color or pants color by accident. I'll create the functions now that are used to print out the clothing types. We don't need to return anything since we're just printing out information. And just as with the structures, I'll copy and paste this function and just change the names. We also need to derive debug on our structures. That way we can print out the information using the debug token as we're using in the printline macro. We also need to derive debug on the color enumeration that was provided to us. Now that our functions are created, we can start utilizing them in our main function. We'll create some colors. So here we have our colors for each type of clothing item, and now we can call our functions. Now that we have our function calls created, we can walk through the program and see how it works. I'll split the view so we can see all of the code. So at the very beginning, we have our color enumeration. This simply allows a specific color to be chosen for each clothing item. Next, we have our new types. We have a new type for a shirt color, shoes color, and a pants color. For each structure, we're implementing functionality using the impl keyword, and we're creating a function named new. The new function accepts a color variable, which is the color enumeration type. It then returns the structure. It's a tuple structure, as we can see by the parentheses, so we create a new one using parentheses and the name of the variable. That's all done 3 times, one for each type. And we also derive debug, that way we can print out which colors we get. Next, we have our functions here on the left. We have a function to print out the shirt color, shoes, and pants color, and we simply just call a println macro with each one. In our main function, we're creating a shirt color, pants color, and shoes color by using the new function implementation on each color type. We then supply a color for each one, and then use these color variables in the appropriate print functions. Now, the reason for this activity in the new types is demonstrated here, where we're calling similar function names with similar pieces of data, all kind of grouped up. If we didn't have the new types and we just had colors only, so if I just delete these as an example, and then we'll change all these types just to color, then what could end up happening is we mix up the shirt colors with the shoes colors. So perhaps we accidentally mix this up. So we do shoes for the pants, or sorry, we do shoes for the shirt, and then maybe the shoes color is the shirt color. Now, if we were to save this and compile it, then what would happen is we won't get an error and then everything will be fine, except we accidentally switched the shoe color and it's getting printed as a shirt color. And if you were to extrapolate this to a business application and instead of just 3 things, you have maybe 50 things, then it could be really easy to mix up your variables and your function calls. But with the new types, we have a specific type for each piece of functionality and each piece of data, which means if we were to accidentally switch it again, so if we switch the shoes again and we switch with the shirt, we will get an error because, as we can see, our shoes color function that prints out the shoes color only accepts a shoes color type. And as we can see, our shoes color is a shoes color type, and we're giving it a shirt color, which is a shirt color type. So we'll get an error. So I'll just do that right now just to show you. I'll do a cargo check since we don't need to run it. As we can see, we have a print shirt color function it's called with a mismatch types error. And it expected a shirt color, but we gave it a shoes color. So right away, before we can even have the ability to run our program, we see that there's an error in our program that needs to be corrected. So if I just switch that back and then do another check, looks like we're good. So I'll just run it and make sure that everything makes sense. So here we have the shirt color is a shirt color and it's gray. That's good. Pants color, it's pants color and it's a blue. That's good. And a shoes color, which is a shoes color and it's white, which is good too. So as you can see, if you use new types in this fashion, then it becomes impossible to accidentally mix up your variable names, and you won't be able to mix up your colors with your different clothes items. Additionally, with these new types, you're able to restrict certain colors to certain clothes items. So for example, if you didn't want your shirt color to ever be purple, you can match on the color. And if the color is purple, then we can return an error. Purple not allowed, and then this would just get changed to a result type. And then if it's not purple, then we can just return the color. And so then all we need to do is just change your shirt color call here and just make sure that we account for the result. And doing it in this fashion allows you to restrict the colors to certain things for each specific item. So there's only a few here, a few colors, but if you had a list of thousands of items, then this could be pretty valuable since usually products only come with certain configurations. And you could expand this to include different sizes, different cuts, different styles, ones for men, women, children, etc. And again, since this is all checked by the compiler, it'll let you know if you make any mistakes before you even get a chance to run the program. This concludes the activity on the new type pattern. I'll see you in the next presentation.